name is Naveen Kumar. I am 11 years old. I am from Bihar, but I am living in Ludhiana for my education purpose. So today we are going to what you can call discuss about the Big Bang in brief. So I think we have already made an presentation about that, but we didn't go in deep how these things were done, how the material was found till now. So yes, today we are going in what we can call depth. So I think we should start by now. So I think most of the people know what happened in the Big Bang. Big Bang was just a singularity which expanded into our universe. So we are going to start right now. So the Big Bang theory is the leading explanation for the origin of the universe. It describes how the universe expanded from a hot dense state to approximately 13.8 billion years ago. So this event marks the beginning of space, time and all matter. So like as you can see in the picture, there was a singularity which expanded into our universe and that was roughly around 13.8 billion years ago. So okay, now moving to the next one topic. It is about how these things were what we call how this concept came into existence. So like in the 1920s, Edwin Hubble proposed a what we call theory of the Big Bang theory. What he discovered that he was discovering that when he was what you can call observing a galaxy, he noticed that it is going far and far away from him. So this thing also helped us to measure what we call the Hubble constant and the redshift and the other things. So, like the concept of an expanding universe was first proposed by Edwin Hubble in the 1920s. George Lemaître independently suggested the idea of primordial atoms leading to the Big Bang theory. Before this theory, many believed the universe was static and unchanging. So, as you can see, the first thing was proposed by the Edwin Hubble in 1920s and it also helped us to measure the Hubble constant. So I think the Hubble constant is about 76 kilometers per megaparsec. I think so. That it is around this thing only. And as you can see in the picture, the red shift and the blue shift, right? Hello, Aryan. Do you know about the red shift and the blue shift? Hello, Aryan.
Hello, yes, Aryan.
So, do you know about the red shift? Hello.
You say now. Wait 2 seconds, my sister is disturbing.
Okay. So,
श्रेया आपके पास भी कोई क्वेश्चन है तो आप पूछ सकते हैं ठीक है यू हैव एनी
Yes, sir.
क्वेश्चन ठीक है आर्यन श्रेया दीदी इज आल्सो ज्वाइन
Shreya, do you know about the red shift? What it is?
Uh, Actually, I don't know more about it, and so if it's okay, so you can explain me.
So, okay, I will explain. So, redshift it is just a fundamental concept in astronomy which occurs when the light from distant stars and galaxies or other celestial bodies stretches toward the red end of the spectrum due to expansion of the universe, motion away from the observer, and gravitational pull. So maybe like if I am a person observing a galaxy, and because of the expansion of the universe, it will go further and further away from me, and the what you call wave will become larger. And when the wave becomes larger, it is red. So yeah, it just depends on the where and how much speed it is going away from us. So this is the redshift. And there is also one more thing, as you can see, So there were many what you can call steps to measure the Hubble constant, which is also helped us a lot. So the redshift is just the expansion of the universe and moving things moving away from us. So yes,
Aryan have a question. He is raising hand.
hello Aryan. Hello Aryan.
Hello, Aryan.
Yes,
Can
so
you send me some pictures of some galaxies? Because I saw in one video, scientists first click the picture of galaxies, then they add some colors, and
okay. So I think you didn't understand what the redshift is. So like if
no, I am asking, can you send some pictures of some galaxies?
okay, I will send you that only. After I think after this class I will send you.
But real pictures.
What can call?
They are real pictures because I saw scientists add some colors and do brightness full, and then they upload that photos.
Okay. I will I think send you at the end of the what we call presentation. So okay. So I did do any does anybody have a question about the redshift or the expansion of the universe?
No, Aryan, you can continue.
Okay. So moving to the singularity. So the Big Bang theory posits that the universe began from a singularity. I think there's some noise. So a singularity is the point where density and temperature become infinite, and thus this state of contained all the mass and the energy of the universe. So as you can see in the end of that, you can see that is there a point which is infinitely small and has all the mass and the energy of the universe. So like this thing also happens in black holes. Black holes also have a singularity which is infinitely small. Okay. So the this singularity is a point of infinite density and zero volume where the laws of the physics break, space and time curvature is infinite and quantum gravity dominates. So like this thing happened around 13.8 billion years ago when this thing expanded at a what you can call very fast rate. So there are many key stages also. I think there are I think four to five or six. The Planck era, the grand unified theory, electroweak era, quark era, hadron era, and the cosmic expansion. And as you can see in the picture, I think they are also mentioned there. The first is of the Planck era, which is around 10 raised to the power of minus 36 seconds. So yeah, and we also have some proof of it, like the CMB or the cosmic microwave background radiation. So and the redshift of distant galaxy, it also helps us to discover that there was a singularity where the temperature and density was infinite. So if you see that these singularity are everywhere in the universe, like in black holes, the Big Bang, etc. So the in black holes, what happened? The mass is just concentrated in one point, which is called the singularity, and where density is infinite and has some what we call similarities between the Big Bang singularity also. Okay, so there are many opposing theories also, like I did not remember the name, but I think there are many opposing theories also, like which say that the universe was eternal and it was already existing, but the most proved one is the Big Bang theory. So I think, does anybody have a question related to this topic? Hello?
No, Aryan, I think nobody have.
Okay.
Aryan raised the hand. Yes, Aryan, please.
Hello, Aryan. Hello, Aryan. Are you here?
Yes,
Okay, so what was the question?
I have a question that you say that is infinity, but infinity is a lot. We can even not count it. Then where all these things come to make
Okay.
singularity?
So I think, like in on the Earth, nobody can answer that question. How did the Big Bang really happen? Why was the singularity there, etc.? And how that singularity reached infinite mass, temperature, etc. So many believe that God did all this and He made all the laws, etc. But nobody really knows, nobody has a question answer for this thing. So yeah, so it is just what you can call unanswerable right now, and nobody right now has figured it out. So okay, so was that enough? Cause right now nobody has the answer for that. So okay,
Okay.
so now we are moving to the expansion of the universe. So as you can see in the picture, that the universe got larger and larger with time, and the following the initial singularity, the universe began to expand really quickly. This expansion is often described as space itself stretching rather than objects moving through space. So this rate of expansion has changed over time due to dark matter and dark energy. So I think most of the people know about gravity and dark energy. So what we can call, um like, everybody knows that this thing started around 13.8 billion years ago, and it accelerated due to dark energy around 5 billion years ago. So like around when our solar system was going to form, around 1 billion later, this thing, dark energy, just accelerated the expansion of the universe. So today every galaxy is moving away from us. So yeah, some, and how we know that is because of the redshift, which I have explained later, and the CMBs, and many more things like supernova observations, etc. And there are theories also like the Big Bang theory and dark energy, etc. So I think so. What is our current understanding? It is of the, we only know three things of the three. We only know three things. The expansion rate of the universe is about 67 kilometers per megaparsec. So this thing is just what we call huge, and the age of the universe, we know that it is about 13.8 billion years ago, and the size of the observable universe is about 93 billion years ago. light years. So does anybody have a question? Hello, does anybody have a question? So okay, I will. So there is one misconception. So if our universe is 13.8 billion years ago, so it should have the same diameter around, but that is not the case because step one, like uh, if you use the Hubble constant, I will tell you how to use it. So 13.8 billion years multiplied by, okay, I think I will do it by this way. So if the universe age is about 13.8 billion years ago, so if we multiply that by 67 kilometers per second by the Hubble constant, so it will, what you can call, then equals to what you can call 14.5 billion light years. So and we are also dividing by the uh, what we call megaparsec also. So that will result to 14.5 billion light years. And then, so since the universe expanded, we need a account for the expansion factor. So they increase the distance to approximately 46.5 billion light years. And so considering the, we are considering many things, and when we consider the universe curvature also, so then which is roughly around twice the distance. So what was that? 46.5 billion light years. Because of this expansion factors, like due to time, it is also increasing the expansion. And then because of the universe curvature and expansion, that is roughly around twice, which results to the final answer of 93 billion light years. So yeah, but this only means that we can see up to objects around 46.5 billion light years. So light beyond the 46.5 billion light years has not reached us now.
Yes, Aryan have a question. Yes, Aryan, you have raised the hand up.
Okay. Hello, Aryan, do you have, what's the question?
How many types of singularity are there?
What did, can you repeat?
How many types of singularity present in the universe?
Okay. So I will give you some mathematical singularities. I think I know only three of them. The surface singularity, infinite density on a surface like the black hole horizon, and the point singularity, which is just a point of infinite density and infinitely small. The line density, the line singularity. So I think this also has infinite density and along a line like the cosmic string. But I think I will not go deep in this right now, cause this is just too much of that thing. And there are many also more, like the physical singularities, the gravitational singularity, like it it has some connections with black holes and the Big Bang also. So I think I will say some black hole singularities like the Schwarzschild singularity. Schwarzschild singularity is just a black hole which is uncharged and non-rotating, and the Kerr singularity, rotating black hole. So I think I only know these five or six singularities, but I will make a presentation of it also. But today we will not go deep into these singularities also. So was that enough? But I will but I will tell,
Yes.
okay. So but I will tell you
In
that, so there are many more singularities, but I I only know about five or six of them. So yeah.
so can you take a class on next Sunday topic based on singularity?
Okay. Okay, I will take that. I will make a presentation about singularities on next Sunday. But now moving to our topic, which is about cosmic microwave background, the CMB. So the CMB is just the afterglow radiation from the Big Bang discovered in 1965. It provides strong evidence for the Big Bang theory, showing a uniform temperature across the universe. So the CMB is a key tool for understanding the early universe conditions. So I think, Shreya, are you here?
Yes,
Okay, so can you read this slide for everyone?
yeah, sure. The CMB is the afterglow radiation from the Big Bang discovered in 1965. It provides strong evidence for the Big Bang theory, showing a uniform temperature across the universe. The CMB is a king tool for understanding the early universe conditions. I think all of them you have explained
Okay, so I think I will go more deep in this CMB. So like I will tell some properties, but I think it was discovered in 1965. So I will give you some properties of that also. So like it was, I think, 2 point, the temperature at that time was very low, around 2.2, like almost minus 700, minus 270.425 Celsius, around absolute zero. So like polarization was also there, but I think I will discuss it sometimes later. So this thing just provides the evidence for the Big Bang theory and also supports some other theories also. So and it helps also helps determine cosmological parameters like the Hubble constant, that it was true. So I think the first detected CMB fluctuation was in the 1989 to 1993. So yeah, I think this map you are seeing right now was made in 2001 or 2010. I don't know the exact dates. So yeah, some future missions are also going around this topic. So like as you can see in the picture, there are some blue and red surfaces, like the Doppler effect. This is cause of the Doppler effect, the gravitational lensing, and many more things. So yeah, this is the color, as you can see, is because of these top things. So okay, I think this thing is the CMBs are covered for now. So does anybody have questions related to this topic? I don't think so. So formation of basic elements. So Aryan, can you read this one for us?
Yes. In the first few minutes after the Big Bang, simple elements were formed through nuclear eccentricities. Hydrogen, helium, and small
Amount.
amounts of lithium were created during this period. This process set the stage for the formation of stars and galaxies.
Okay. So I will also tell you what is. I think a new person has joined. So thanks for joining. And if you have any question, you can ask. So like the formation of these things. So Big Bang nucleosynthesis. So the protons and neutrons and electrons were formed around 1 second after the Big Bang, and these things, protons and neutrons, combine into atomic nuclei like hydrogen, helium, and some amounts of lithium also, as that is written there. And this thing lasted about 20 minutes forming. This took around 20 minutes of forming. So at that time, hydrogen was about 75% of the universe of, and helium 25%, and other light elements were very little. So the stellar, there are many things also like the stellar nucleosynthesis. So the stars formed around 100 million years after the Big Bang theory. So these nuclear reactions within stars created heavy elements. Hydrogen fused into helium, helium fused into carbon, nitrogen, oxygen. So many things heard also. So the supernova explosion disappeared elements into space like the gold, platinum. I think you already know these things. So these also created a chain of things like proton chain, hydrogen, helium fused into helium. So as you can see in the picture given, this thing is shown there. This is a mass of. I think we have got a. I think we have got a question. Is mass is the wait a minute. Let me see. Okay, I got the question. So is the mass of the universe constant? So I think it was. So the question is goes like, the mass of is the mass of universe constant? So I think because of the, I think I will just give a simple answer. Maybe I think so. For me, it is yes. But what you can say, because of the conversations of mass and energy in physics and general relativity, the total mass of the energy is conserved. This means that sum of energy and mass is remains constant. So it is constant. The mass of the universe is just constant. So yeah, this is the this was just a simple answer. It yes. So yes. So as you can see, where was so as you can see in the picture, protons and neutrons, deuterium, hydrogen, and many more things had formed by the synthesis. Okay. So I think this this topic is covered. So does anybody have a question? Hello? Does anybody have a question related to this topic? I don't think so. So okay, moving to the next one. So the structure formation. So has the universe expanded and cooled? These matter began to clump together under gravity. This led to the formation of gravity. Okay, I think so. Hello, Shreya. Hello, Shreya. Are you here?
Yes, yes.
So can you read this slide for everyone?
Okay. As the universe expanded and cooled, matter began to clamp together under gravity. This led to the formation of stars, galaxies, and larger structures known as galaxy clusters. The distribution of these structures provided insight into the universe evolution.
Okay, so like this, as the universe expanded and cooled, matter began to clump together under gravity. So this led to the formation of stars, galaxies, and larger structures known as galaxy clusters. So the distribution of these structures provide insights into the universe evolution. So as you can see in the picture, that many things happened, like many structures were formed like the galaxy clusters. So I will tell you. So I will tell you how there is a timeline begin. So around 13.8 billion years ago, universe began as a singularity inflation around 10 raised to the power of minus 32 seconds. A rapid expansion smooths out universe and recombination around 380,000 years. Electrons, protons combine into neutral atoms. First travels around 100 million years ago, and the galaxy formation around 500 million years ago. Star gas and dust, dark matter, etc. So, as this did, there were also forming galaxy clusters. So, like what happened, like gravitational collapse, matter and clumps are under gravity, and dark matter halo formation. So, dark matter provides gravitational scaffolding for these galaxy clusters. So, gas cooling was also there. So, gas cooled down and formed stars. So, many mergers were also there, like galaxy collide, merge, and grow. So many, and to control all of these, supernova, black holes regulated this star formation. If there were too many stars, that would be also a problem. So maybe like I will give you some key places also, like the dark matter, dark energy, normal matter, black holes, etc. And some large scale structures were of these galaxy clusters, superclusters, filaments, void networks. So as the name suggests, void is just an empty space, which, and I think the biggest one is about 200 million light years across. So yeah, this was there. So some theoretical frameworks are also there, like the cold dark matter and lambda, including dark energy. So I think most of the people know lambda. It is just a symbol developed by one of the greatest scientists, Albert Einstein, and many things were also there, like modified Newtonian dynamics, etc. So like there are many questions of it also, like what is the dark matter nature, how these things happened in just a short amount of time. So yeah, so does anybody have a question for me?
Aryan have raised the hand, and also you have seen your
Yes.
chat box.
Hello Aryan, what's the question? Hello Aryan, what's the question?
When NASA send people to Mars,
Yes. Okay, I think so, around I think it will take a time. I think around 2050, this would be the time when the first person will step on the Mars. I don't know when it will be, so it will just wait. So I think
Some other
there.
person is also say message you, Aryan. You can check it.
Okay, so question by Abhivardhan Singh. So is the formation of new atoms, electrons, and protons is still going on, as the expansion of the universe is still going on? So yes, the formation of new atoms, electrons and protons is still happening, but at a very slow rate. This process is known as nucleosynthesis. I think I had already covered this topic in the previous slides. So yeah, many it is still going on, and the expansion of the universe is still going on. So yeah, it is still going on, but at a very slow amount, because I think I just received one more question. So then how the mass is constant? So the concept of constant mass in the universe is like, I think it will take some time for me also. So like the mass energy conversation. So the universe total mass energy remains constant, but the formation of mass and energy changes over time. I think I will. This is just. I think there is a Einstein famous equation also for that, but I don't remember it right now. I think it was um like what happens that when everything has what you can call opposite things, like when something is formed, something is also destroyed also with time. So like mass creation and annihilation. So like new particles, electron, protons are created through various processes like pair production, proton formation, stellar nucleosynthesis. However, these processes are balanced by particle and antiparticle annihilation, nuclear reaction, and radioactive decay. I think you already know about the radioactive decay. So like many things are happening like energy into mass, mass into energy, etc. So this is just balanced by mass creation and annihilation. And I think there is a famous Einstein, what you call that thing also, like he has made a great equation for it. I think I will send it in the group. I'm just giving. I'm going to send that equation in the group. Uh,
You can share after some time, Aryan. So if firstly you have to complete your this,
okay,
and Vardhanji, actually Aryan is only 10 years old, and right now he is studying in sixth grade. So he tried to um, uh, answer more and more. So you have satisfied, then it's okay. And Aryan, you have to complete your uh,
okay.
and
So
also Seria is also joined, and Aryan is also, and another person is also joined. Okay,
okay,
maybe new person is also joined soon.
okay. I think I will give you the. I will give. Okay, I have given to you, so you can also give that into the chat. So like, is it in the chat? So I will. What you call?
I've just
So
sent it.
I'm just breaking it down. E equals to the total energy including rest mass and the energy and kinetic energy. So P is the momentum related to the particles motion. So C is the speed of light. You know that it is around 299,792,458 meters per second, and mass M equals the rest mass, the mass of an object at rest. So like if I discuss that this equation, much time will be lost. I think so. I will what you can call what you can summarize it in some other time, but this thing will take some time. I think so. So I think I will we will discuss it later. So yeah, as you can see, move to the next topic. So it is about dark matter. So dark matter is an unseen form of matter that does not emit light but exerts gravitational influence. So dark energy is a mysterious force driving the acceleration expansion of the universe. Together they make up about 95% of the universe total energy content. So dark energy is about 68.3 single largest constituent of the universe tends to drive the universe apart. No interaction with normal matter can be thought has the fifth fundamental force. So dark matter is about 26.8%. Second largest constituent of the universe tends to drive universe together. Interacts with normal matter by gravity has the gravitational lensing. Dark matter is not antimatter or black holes. So yeah, this was that. So now we are going to our current understandings of the universe. So I think I have already discussed in some other slides, around 5 or 6. So the universe is currently expanding at an acceleration rate due to dark energy. Observations show that galaxies are moving away from the each other, supporting the Big Bang model. The universe is also approximately flat according to measurements from the CMB. So, like I have already discussed, the Hubble constant, the age of the universe, and many more things, the inflation, etc. So, I also already so like there are many more alternative theories while the Big Bang is widely expected. So, alternative theories exist such as the steady state theory. These theories attempt to explain cosmic phenomena without the need for a singular beginning. However, they lack the observational support that the Big Bang theory has. So, like many more things are there also, like the alternative theory where the universe is just was or eternal and was already there. So many things have are also there. So key evidence supporting the universe, the Big Bang, the abundance of light and universe matches predictions from Big Bang nucleosynthesis. The cosmic microwave background radiation provides a snapshot of the early universe. The observation of distant galaxies show redshift indicating the universe expansion. So as you can see, there are many more things like the nucleosynthesis that support Big Bang, the CMBs, etc., the redshift. So yeah, many more things are supporting this concept. So the role of observations. So observations around the world and in space have contributed to our understanding of the Big Bang. So the Hubble Space Telescope has provided deep field images revealing distant galaxies. These observations help astronomers piece together the universe together. So like these things are all also helping us to discover many more things like the galaxy photos, etc. So yeah. So Shreya, can you read this one? Hello.
Yes.
Okay.
The future of the universe. Current models suggest various scenarios for the universe's ultimate fate, including heat death or the big crunch. The future depends on the properties of dark energy and the overall geometry of the universe. Ongoing research aims to better understand these cosmic mysteries. I read it, Aryan. Hello, am I audible?
Okay. Hello, are you there? Hello?
Hello.
Yes. So I think there
Um,
was some okay. So I think there was some issue in the voice. Okay. Uh, so the future of the universe, it are very what we call. There are many things like the big crush, the big rip, the big freeze. So yeah, this thing helps us understand the cosmic mysteries, as you can see how the universe will end, etc. So there are many misconceptions of also there, like many people mistakenly think the Big Bang was an explosion in space rather than an explosion of expansion of space. So the Big Bang does not describe the formation of the universe from nothing, but rather a transformation of state. So the theory does not address what happened before the Big Bang theory. So yeah, it is the Big Bang was just an expansion of space. So I think we have already discussed these things. So what it has on impact on modern physics. So the Big Bang theory has influenced many fields including cosmology, astrophysics, and particle physics. So it has promoted new questions about the nature of time, space, and matter. The theory has also led to advancements in technology and observational techniques. Okay, so like as you can see, it also helps us to understand what happened, the laws of the universe, etc. So hello Aryan. Aryan,
Hello, yes.
so can you read this one for everyone?
Yes. Public interest and education. The Big Bang captures public interest and serves a gateway to broader scientific scientific topic, educational program and documentaries often feature features the Big Bang explain cosmically outreach efforts aim to inspire future generation of scientists.
Okay, so there are many more things going on to educate people about the Big Bang theory and to explain cosmology. So yeah, this thing will aim to inspire the future generation of scientists like you and me. So the physics for so the Big Bang theory raises profound questions about the nature of existence and the universe origin. It challenges human understanding of time and reality. Philosophers and scientists often discuss its implications for meaning and purpose. So in in philosophy, there are many questions about how the universe began, things, etc. Because in the modern, in ancient times, as you see, that there were many, we did not know that the Big Bang was there, the expansion of the universe was there. We were just having questions, but no real answers. So yeah, it uh, now we have some connection with philosophers also. So yeah, so now I think we are also at the end of our presentation, the future research and directions. So the scientists are exploring dark matter and dark energy to understand the universe composition better. Upcoming space missions aims to gather more data on cosmic microwave background fluctuations. So research into gravitational waves also promises to insights into cosmic events. So, like we are also studying on gravitational waves, dark matter, etc., for better understandings. So, the Big Bang in culture, so it has influenced art, literature, and popular cultures. It serves a metaphor for creation and transformation in various contexts. So, many documents and films explored its theme, making science accessible to the public. So conclusion. So the Big Bang theory remains a coronation modern cosmology and our understanding of the universe. Ongoing research continues to define our knowledge of its application. As we learn, the Big Bang will undoubtedly remain a subject of fascination and inquiry. So feel free to modify or expand any slides. So okay, now moving to the now we are think are at the end. Thanks for joining us today. So I hope everybody like this presentation. So if somebody has a question right now for me, okay, Aryan, what's the question?
आर्यन आप अपना वीडियो ऑन कर लीजिए बेटा ना.
Okay.
And Seria, you have any question like the general science also? You can also guide the Aryan also, na? So
Yes, uncle. Uh,
आप अभी किस स्टैंडर्ड में है? Which standard you have reading?
I'm reading currently in 7th standard.
7. अच्छा अच्छा, Aryan 6 में है. अच्छा. Also you can also guide in better for the Aryan also.
Actually, he knows better than me. So,
Okay. So you can ask also the general question also for Aryan, not an issue.
I think
So,
Aryan is more capable than me in science. So, he is better to teach me.
so I think so. Aryan has left. I think
Yes.
he had
Uh,
raised his hand. Yeah.
yes.
Yeah.
You can talk with Shreya Aryan.
So Shreya, was the presentation good?
Not good. It was like brilliant. I just appreciate you.
Okay. So yeah, and I think the next presentation would be about the singularities and stuff, how the universe remains constant, etc. So like I think someone had joined earlier who was asking this question. I think he was Adharvadhan Singh. I think so. It was his name. He was asking this question. So yeah, he I think asked about how are new atoms still what we call forming, and is the universe expansion still going on? So yeah, so I think many more things were also there, and I think yeah, as you can see, there was the formula that I gave. So like yes, e raised to the power of 2 p c and raised to the power of 2 plus m and c raised to the power of 2 and then 2 raised to the power of 2. So what you can call this thing is also just somewhat advanced to me also. Like E is the energy and m is the mass at rest and p is the constant mass and c, as you know, that it is the light, the speed of light. Yeah.
Aryan is joined now.
Yes. Yeah.
Yes, Aryan, please
Hello.
speak.
Yes. Hello, Aryan. What's your question?
In the next Sunday,
Yes.
can you conduct a topic based on singularity?
Yeah, I had already told that, right? Singular.
Yes.
I will make the presentation on singularities and stuff. Yeah.
Okay.
Okay. So, any more suggestions? What should I put in the presentation that you like? So, like only singularities, right? Or any other stuff, black holes, stars, etc.
So, I think if you have not presented this topic, so you can present this topic that formation of every planet, whether it is like you can say Pluto type planet or it's like normal planet. So how
Yes.
the formation and what's the temperature, currently temperature. So
Okay, I think I can just what you can call say it right now how everything formed. So like in around 4 billion years ago, that's the age of our solar system, there was a nebula or just a cloud of gas, and there was a disturbance of a supernova of I think no, there was a kilonova. Kilonova is when two neutron stars collide. I think Aryan had some questions related to it also. Kilonova that called that made some disturbances, and then the star formation was happening, and then I think so you know about the protoplanetary disk, which is around the um, star, which is around the star. It's like Saturn, but the ring was very big and had much material. And because of that material, we came into existence. And I think the first planet created was Jupiter. So I think I will make a presentation of it also. So yes, this was it.
Yes, Shreya, you have understand all things.
Yes.
Yes.
Yes, uncle.
So you have to join also in Sunday, every Sunday same link. ठीक है, आप ज्वाइन कर
Yes, sir.
लीजिएगा। आपके पास कुछ भी क्वेश्चन हो साइंस से, यू कैन आस्क विदाउट एनी हेजिटेशन ना। And also you
Yeah.
can share your family and friend also if anyone want to join and anyone want to add some slide also.
Actually, in my friends group, nobody is interested in science. So,
Yes,
and
yes.
my younger brother is so young to understand all this.
Hmm.
So he'll not be able to. Uh,
Understand, yes, yes. नहीं, actually मतलब आर्यन भी only he is studying sixth standard, but he is read and efforts add the effort. Then he is speak in front of people and in front of presentation also. So you have to, if your classes also, if anybody want to join the session every Sunday and um, उनको कुछ सजेशंस हो या कुछ वो जानना चाह रहा तो आप करा सकते हैं।
yes, sir, sure.
ठीक है, तो आपको आप अंडरस्टैंड कर रहे हैं ना, आपको ठीक तो लगा ना।
बहुत अच्छा लगा सर।
चलिए, थैंक यू सो मच फॉर ज्वाइनिंग अस एंड आपने अच्छा किया ज्वाइन कर लिया, क्योंकि आप भी 7 में है तो आपको अच्छा और आगे इस चीज में आपको होगा चीज।
Yes.
Yeah.
ठीक है आर्यन, आई हैव जस्ट सेंड इट टू यू, यू कैन ज्वाइन द फास्ट। एक्चुअली मृत्युंजय भी इज ज्वाइन ओवर देयर। ओके, आई हैव जस्ट
Okay.
सेंड इट टू यू। ओके
I
ओके
think
श्रेया, थैंक यस श्रेया कुछ पूछ रहे थे, आप बताइए।
I think Aryan can send me presentation
Yes, yes,
that.
yes. I have sent it to Aryan only present. You can just I have WhatsApp you. If you want to mail, then I have also mail you.
Yes, even he can send the PDF on the group that Pankaj sir made. That kids
पंकज सर
science.
को मैंने मैसेज किया था बट वो डालते ही नहीं है, अब क्या करें अब उनको।
Me,
Uh,
Shreya,
huh?
are you on the what can call my group? Are you in my group?
नहीं सर,
No.
Okay.
मैं ऐड कर देता हूँ बेटा ना।
Hmm. Session. Okay. It is going to end in 12.
Yes, Aryan, you can join over there. Just I am go join this.
Okay. Okay, I will join. So,
Okay, okay, Surya, I'm just I have sent it to you all things. Okay, thank you so much for joining us. Actually, other classes also started. Aryan.
That's good for me. So while joining this, because it's so knowledgeable and so interesting topics that Aryan has presented over here, so
yeah.
it's so good for me.
Yeah,
And
thank you.
yes, sir. Thank you, sir.
Yes,
Okay.
yes, thank you so much. Okay, Aryan, have a
Okay.
good day. You can join over there next.
Yeah.